Weird.
Okay, let's make sure we all get to the same page when we isolate the absolute value bars. What are the two steps in order to get the absolute value by itself? Add 11. So that gives us 2 times the absolute value of u equals what? 0. And then what? Divide by 2. And let's go ahead, what's inside there? So inside we've got a 3x plus 6. But that's off limits, we can't touch that. Then we divide by 2, you said, that's correct. So that cancels. And then we get the absolute value of 3x plus 6 equals what? What's 0 divided by 2? 0. Okay, good. So there's the step where we isolated the absolute value. Now, what's our next step? We got to make our trade, right? Because we can't do anything inside absolute value bars. So whatever's inside, we set equal to 0 or negative 0 is kind of weird, isn't it? What is negative 0? Just 0. So in this case, this is kind of a weird one. In this case, we only get one equation, but normally we'd get 2. Right? So we end up getting the equation 3x plus 6 equals 0, and then we would just solve that, right? So we'd subtract 6 and divide by 3. What are we going to get when all the dust settles? Then if I subtract 6 and divide by 3, I get negative 2, don't I? Right? Okay? You get the idea? All right. Why don't you, oh, no, never mind. Okay, so now let's look at inequalities. Okay, they're really similar, really similar. So what if we're going to solve an inequality where we end up, after we isolate the absolute value, we get the absolute value of something, call it u, is less than or equal to a number. How is that going to change? Now, instead of trading for 2 equations, we're going to trade for 2 inequalities this time, right? But the question is, what are they? Because are they greater than inequalities or less than inequalities? We need 2 of them. We can look at the picture, and that helps us understand what's going on here, right? So once again, we want to know where's the intersection of the function, of the graph y equals absolute value of u, which is the v, right? And then what about this part? It's not y equals, it's y is less than or equal to this time, right? What if we graph y is less than or equal to a? Well, here's the boundary line. Like I said, move that thing a little bit. It should be right there. Here's the boundary line. Y equals a is right there, right? But if you think back to the stuff we talked about at the very beginning of the year, when we want to graph an inequality, we want to get everything that's, in this case, that's equal to a, so that's the line, but how would we represent everything that's less than? If y is less than the boundary line, what are we going to do? In the xy plane, where are all the places in the xy plane that are less, where y is less than a? If y equals a on this boundary line, y is the vertical variable, right? So when y is greater than something, it must mean it's above it, right? If y is less than a number, it must mean that it's below it, right? So this whole shaded region down here then is the graph of y is less than or equal to a. It's not just a line, it's a half plane, right? It's the boundary line plus the half plane depth. So now we're looking for an intersection that's a lot bigger than just 2 points. We want to know, where does this shaded half plane intersect with the red V? Well, wouldn't you agree that they intersect right here? Right? They intersect starting at that point, but all down there they're intersecting, and all up here they're intersecting until I get up to that point, and then they don't intersect anymore, right? We just want the x values where they're intersecting. So what if I take that part of the V and I squash it onto the x-axis? Because I just want the x values where that's happening. Wouldn't you agree that's just the x values between the two endpoints, right? It's not just positive A and negative A this time, it's everything in between also, right? So we could represent that by this number line, right? This segment on the number line. Everything between negative A and positive A, but we're including, this time, because we've got the equal sign included, we're including the endpoints also, right? So how do we say that? Well, that's an and inequality, compound inequality, isn't it, right? It's an and inequality because we have two endpoints on this, so we need two inequalities at the same time to describe what the solution is, right? What are the two inequalities? Well, we know that U has to be greater than or equal to negative A, right? And it has to be less than or equal to positive A, so it's everything in between. So here's our trick. And at first it might seem kind of confusing. How are you going to keep all these straight? Well, there's only three, and one of them's an equation, which is easy. There's only two inequalities. But here's the pattern. If you ever start off with something like that, where you have an isolated absolute value is less than or equal to a number, it has to do with the direction of that inequality sign, doesn't it? If it's less than or equal to, then that's always going to turn into that kind of a compound inequality. But look at the problem we just solved. We can't do anything with this because it has absolute values in it. And we can't do anything inside the absolute values, right? But once I make this trade, the absolute values are gone, and now we can solve the inequality. Okay, let's do an example. It always helps to do an example. Okay, and there's a quick summary of what we just did, right? Okay, so that's when we start with something like this, we end up with something like that, right? Okay. So here's an example. Okay, what are we going to do first? I've got this absolute value inequality. What do we always do first when we're doing absolute value equations and inequalities? Isolate the absolute value. Very good. Okay, so I'm going to put this inside the absolute value, so we're not tempted. We can't do anything inside. What are the two steps? Add 1. Okay, so if we add 1, that's going to give us 2 times the absolute value of U is less than 6, right? And what's my U? I guess we'll write that down. The U is a 3x plus 9. Okay, and then what? Divide by 2. Okay, so if I divide by 2, we can just get the absolute value. We get the absolute value of 3x plus 9 is less than, what's 6 divided by 2? Okay? So we isolated the absolute value. That's good. That's what all that stuff was about. Now what? What's our trick? If I have the absolute value of hand, or U, or whatever you want to call it, is less than 3, what's the trade I make here? What do you think, Matthew? What's the trade I make here on this one? I'll go back one slide. Maybe that helps. Wasn't my U, was it 3x plus 9? Right, on my problem? I've got the absolute value of U, which is 3x plus 9 is less than 3. Well, what did I do here? Right? Whatever was inside goes in the middle, and it's going to be greater than negative that number and less than positive that number. Okay, so let's try that again. What do you think? Back to it. There's my u, my 3x plus 9. What am I doing? What do you think? In this one, we don't have any equals, right? So the positive goes there, right? And the negative goes there, doesn't it? Right? Okay, now that looks weird, but we've done that before. We did that at the beginning of the year. We know how to solve those. I got to isolate x like I normally would, right? What are the steps I do to all three parts of that compound inequality to isolate x? Subtract 9. So that's going to give us a 3x in the middle. 3 minus 9 is negative 6. Negative 3 minus 9. Negative 12. Good. And then what's the last step? Divide by 3. Right? And then what do I get? Well, the 3's cancel, so I get my x in the middle, which is what I want. Negative 6 divided by 3 is negative 2. Negative 12 divided by 3. There it is. Right? Okay? Make sense? Okay? Right? No big deal. Okay? The key, though, is this is the important step, I think, right here. You know, going from there down to there. That's the one that you got to remember. Once I isolate the absolute value, whatever's inside goes in the middle. If it's a less than symbol, less than 3, then that means I get negative 3 on the left and positive 3 on the right. Okay? Okay? What about the opposite? What if we're doing, this time we're going to do the same kind of thing, an absolute value inequality, but this time when we isolate the absolute value, it's greater than the number a. Okay, we can go back to our picture though, right? Because just like before, we've got our graph of y equals the absolute value of u. That's that V-shaped graph, right? And then what about over here? What about this part? Y is greater than a. Well, y equals a is my boundary line. Now notice this time it's dashed. Why is it dashed? When I graph y is greater than a, how come I don't have a solid boundary line? Say it again. Because what has to do with that inequality? What's different about this one? Oh, it's not equal to, right? This one we're not including, there's no equal to sign, so we're not including the boundary line, it's just a boundary line, right? But I want all the values of y that are greater than that line, meaning above that line, right? If y is greater than something, it's above it, because y is vertical, right? So that means we've just graphed this whole infinite half plane up here. Everything above that dashed line is the graph of y is greater than a, right? We're looking for the intersection between the v and the shaded half plane. Well, where is it this time? It looks like it's out here, right? That's the part of the v that's in the shaded half plane. That's the part of the v that's above the boundary line, right? It's got to be in 2 sections this time instead of 1, right? So it's summarized right here. Okay, so in other words, if we start off with the absolute value of u, absolute value of something, isolated absolute value is greater than a number, well, some number, call it a, then instead of being the region between the endpoints, it's going to be the extreme values. It's either going to be where u is greater than a, so really big positive values, or u is less than negative a, so very large negative values that are way out there, right? And that's the trick we can always do. Okay, we know that if we start here, we can make this trade. So we can trade the one absolute value equation that we can't do anything with or one absolute value inequality for two simple inequalities that we know how to solve. Okay, so let's try this. How about something like that? What do I do first? Add 6, and that's it, I guess, right? Yeah. There's only one thing to do this time. I have to add 6 to both parts. What's that going to give me? The absolute value of u. Absolute value of u is greater than what? 24. Okay, well, what's my u? Negative 3x plus 21. So we isolated the absolute value. Now here comes the trick. If I have an isolated absolute value is greater than or less than or equal to, well, I know that whatever's inside, I'm going to do something with. What do I do here? If the absolute value is greater than a number, then it's got to be extreme, right? Think about numbers that would work. Would 30 work? Is the absolute value of 30 greater than 24? Everybody focus now. Is that yes or no? Everybody agree? What about 100? Is the absolute value of 100 greater than 24? What about the absolute value of 10? No, it's too small, right? What about the absolute value of negative 10? Doesn't work. It's too small, right? What about the absolute value of negative 100? That works. So it's got to be the extreme values, right? It's got to be the really positive or the really negative ones. So what are the two inequalities I can write then? Either negative 3x plus 21 has to be what? It must be related to this 24. Greater than 24 is one thing I could do, right? One thing I could say is that it's greater than 24. What else could I say? Negative 3x plus 24 is less than negative 24. There you go. Right? And those two things, that's an either-or proposition. It can't be both. It's one or the other. So it's either this statement or this statement, and I just solve them. Those are easy, though, right? So let's solve this one. What are the steps I go through to solve that one? Subtract 21 first. So I get negative 3x is greater than 3. Then what? Okay, so if I divide both sides by negative 3, okay, so that's going to give me, on this side, I'm going to get my negative 1. What do I get over here? X. What happens here? I've got to be careful. I divided by a negative. What do I have to do to an inequality if I divide by a negative? Or multiply by a negative? I got to flip the sign, right? So there's one solution. Okay, how about the other side? Same kind of stuff. If I well, that's supposed to be a 21, isn't it?
Yeah.
So if I subtract 21, what do I get? Negative 3x is less than, what's negative 24 minus 21? Negative 45. Okay, now what? Going to divide by negative 3. So I'm going to get negative 45 divided by negative 3 is what? 15. Over here I get an x, good, but I got to flip the sign, don't I? Because I'm dividing by a negative. I've got to flip that. And there's my answer. Either x is less than negative 1 or x is greater than 15. Okay? All right. Let's try one more just for practice. How much time? What are we at here? Not right now. We got 8 minutes. 8 minutes. Okay, let's just do, this is a quick one. We'll do this very, very quickly. So what do we got to do first?
Subtract 12.
Subtract 12. So if I do that, I get -3 times the absolute value of -2x plus 6. All that stuff's off limits, right?
Yeah.
Can't do anything inside. Is greater than -84. Now what?
Divide.
Okay, I'm going to divide each side through by -3. Okay, that's going to cancel there. That's good. So on this side, I just get the absolute value of -2x plus 6. Over here, -84 divided by -3 is what? Is that 28? Positive 28? Okay, what goes in the middle? But what kind of sign? I gotta flip it, don't I? Because I divided by a negative, I've gotta flip that sign around. Okay, now I isolated the absolute value. So which kind of a trade am I gonna make here? If I have the absolute value of Han, or U, whatever you wanna call it, is less than 28, is that gonna be an and or an or statement? Do I get? Which one's that gonna be? That's and, right? Because we're asking when is it less than, we want to know when is the absolute value of U less than A. If it's less than A, that's that picture right there, isn't it? Right? We want to know where does the half plane below the line intersect with the V, and I just get one segment, right? Just think about that picture. If the picture didn't, if that didn't just leap out at you, and during class today you don't make that connection, I'll put these notes up. But you gotta look at it, because I think once you can make that connection to the picture, you'll never forget. Otherwise, you're gonna memorize this fact and you're gonna forget. Within a week or two of us finishing this section, you'll completely forget it. But if you can remember the picture, in terms of the picture, it'll always stick with you. Okay? When in college, you'll be able to think about this and you'll be able to remember that connection. So just isolated facts, you don't hold those very strongly in your brain. Okay, so this one's got to be because we've got a less than 28. That means I'm going to get a -28 and a positive 28, like that. And we know that in the middle, I'm going to have my -2x plus 6. Now all I got to do is solve that inequality, right? I do want to finish this one, though, because there's something weird that happens here. There's one step here. If I don't do this, it's going to puzzle you when you try it on your own. So what are the steps to get the x by itself? First, I got to subtract 6. Good. Okay. So that's going to give us a -2x, a -34, and a 22, right?
Yeah.
I just subtracted something so the inequality signs stay the same. What's next?
Divide by -2.
Okay, I divide by -2. So that's going to give me a positive 17, an x, and a -11, right?
Yeah.
Okay, but what has to happen?
Flip them.
The signs have to flip. Okay? That's not a good answer, though. That's backwards,
Yeah.
right? That's not the way we'd write it. So what you want to think about here, imagine that I write this on a piece of glass, and I take the piece of glass and I flip it around. What's it going to say if I do that? If I flip it around, the x stays in the middle, but I've got to say the same stuff. I want to say x is greater than -11, but I'm going to write that on this side. And x is less than 17, but I'm going to write that on the right side. Now this matches number line, doesn't it? We want to have the smaller number on the left and the bigger number on the right. Everybody see that?
Yeah.
So if I graphed it, then wouldn't it just look like this?
Yeah.
Well, the -11's on the left and the positive 17's on the right.
Yes.
All right, you got it.